Hi, this is Stephen Brower from Raton Valley Community College. This is for CSIT 256 Computer Architecture and Assembly Language. And this is the overview video for Irvine Chapter 4. There will be specific videos going into demos, kind of like what I did for Chapter 3. Chapter 3, I had multiple demos, and then the final file was also, the main ASM was loaded in. I'll do something similar here. But we'll take a formal look at the move statement, MOV. The most common mistake that I make is I type MOVE, especially if I'm in a hurry, and then when it doesn't compile, I hit myself in the head. I'm like, no! So it's a very, I mean, basically think of it this way. You've been spelling move, MOVE, since like kindergarten, so it's hard to drop the E after so many years of doing it. And a key thing on the move is that the destination is first, the source is second. And if you're having trouble sort of remembering that, if you're having trouble remembering that, if you think of Java, I know you miss Java, right? It's variable equals expression. And so for assignments, the variable is first, and then the expression is second, and Java will calculate the value of the expression and stick it into the variable. Well, what assembly does is it figures out what this value is, and it puts it into what the destination is. So if you're having trouble remembering whether it's source comma destination or destination comma source, just think back to Java and know that the variable goes first, then the equal sign, and then the expression. So I remember in Java, the variable is the destination. So think of it that way. With MOV, we need the same number of bits. So if we're giving a destination as either being an 8-bit variable or an 8-bit register, then we need to make sure the source is also 8 bits or compatible with 8 bits. In the case of an immediate can never be in the destination. An immediate can only be in the source. An immediate is a shortcut way of saying an integer constant. And again, we're dealing with integers only. Chapter 12, we'll get to floating point, but we're dealing with integers only. One of the restrictions, besides the number of bits being the same, is we can't go memory to memory. So the reminder here, they can't both be memory. If you're trying to copy something from one piece of memory to the other, what you have to do is take it from memory onto a register, and then take it from the register and put it in memory. Or later when we see the stack, you can push something onto the stack and then pop it off the stack. If we're trying to take something smaller and trying to load it into a larger item, like let's say we're trying to take an 8-bit variable and load it into a 32-bit register, then we can use either the MOVZX or the MOVSX. So with these, we don't need the number of bits to match. We just need the source to be less than the destination in terms of the number of bits. So an example that I want to do is, suppose we do have an 8-bit variable, and if we do MOVZX into EAX and then reference the 8-bit variable, or I should say 8-bit unsigned variable, that would work. You know, one of the examples I did from Irvine Chapter 3 is I had to use the byte PTR way in terms of referencing the brackets ESI. I could have, and I had to load, in that case, AL for that. I could have done a MOVZX, EAX, comma, and then used the byte pointer for loading the byte in. In terms of whether we use ZX or SX, depends on whether we have signed or unsigned. So if we're dealing with unsigned, we'll use the move ZX. If we're dealing with signed, we'll use the move SX. Remember in Java doing, we'll do it this way. So remember in Java doing count plus plus, right? Oh, on assembly, then that would be inc count. And so one of the reasons why in Java they encourage us to use the plus plus and the minus minus is there's a one-to-one correspondence between those Java commands and assembly commands. That if we in Java did count equal count plus 1, we would be doing that differently in terms of the underlying assembly. But count plus plus would be translated directly into inc count. Now the inc and the dec are only dealing with 1. So the inc is plus 1, the dec is minus 1. We need to use add if we're going to do something with a different value other than plus 1 or minus 1. So formally, the add and the sub will be looked at. And actually, if I can just be lazy for a second, and maybe I shouldn't have done that because of the add, because it's actually changing. If we do think of this as being Java, think of it as being more like variable name plus equals expression. In the sense that in Java, whatever that thing was that we were adding to it, the value was as is, and this was being added to it. So when we do add destination source, the source is being added onto the destination. And then the sub, then the Java-ish Java equivalent of the sub, Java equivalent of the sub would be like the minus equals. The difference is in Java that expression can be complicated. In assembly, it has to be a value. We can't have an expression the same way we do in Java in assembly, which is what this is referring to down here. Yeah, I know I skipped over something. I'll come back. But if we were doing this in Java, or we could do that in Java, that could be a single statement. But in assembly, that would be 6 statements. So the slides for Irvine chapter 4 do show the 6 statements that are needed in order to do this. One of the things that's being done is the negation. So we can negate a value using the negate command. Excuse me. What is going to be introduced in this chapter are the idea of the flags. And it will be mentioned for like the add and the sub, how those different flags are affected. And if you think of it this way, suppose we're dealing with unsigned numbers. I'm sorry. Think of if we're dealing with signed numbers. So suppose we take, well, let's just deal with bytes for a second. Suppose we take 100 and we add to it 100, we would get 200, a positive 200. Well, suppose we were dealing with signed bytes. When we add the 100 and the 100, we're going to overflow. So an overflow flag would be set in that situation because what would happen is the number would be so large, the sign would change. And if we are dealing with signed numbers, a positive and a positive should be a positive, not a negative. Okay, what will happen is we'll talk about the flags. And by the way, there's an addendum in the back of the book that gives all the statements, and it will show how the flags are affected for those statements. MOV does not affect the flags, but add and sub does affect the flags. We're not going to be able to do anything about it until we get to Chapter 6. So in Chapter 6, there are specific jumps based on the flags being set. JZ for jump 0, JC for jump carry, JO for jump overflow, etc. So in Chapter 6, we'll start, in a sense, doing error handling and being able to let the user know, hey, something went wrong. These numbers are too big. Now, I already had jumped ahead and did this and this and this and this in my part 4 demo from chapter 3. Oops. I already went and did that. So I do apologize that I kind of jumped ahead. But that Irvine chapter 3 part 4 demo really should be Irvine chapter 4, well, probably part 4 by that point. These overviews are getting too long. I do apologize. So what I will end up doing is I will do multiple demos in the same file. I'll put the comments just like I did for Irvine chapter 3. Then I will load those multiple videos, and then in terms of the demo file, I'll show the demo file at the very end.